Yeah, so during my time at ESA, I was a part of several projects, and there was actually one project in particular that I found very interesting, and I'd like to share this project with you today because I think it fits very well within the scope of today, namely smart mobility and space opportunities for climate change. So because while aircraft pollution is still a very sensitive subject, of course, and we still don't know whether aircrafts will ever be entirely green. So it's actually very important to start looking for solutions to make them more efficient. So yeah, so it's very important to look for other solutions than just green fuels, and that's what I want to show you today. Because it's a project that was developed by ESA and Inmarsat, and it uses satcom for aviation and for air traffic control. So I have a small video for you that I would like to share. Yeah, it's I will just talk you through. It's a very nice video, I think, to illustrate it. So there's no single solution yet to replace carbon fuels, but our skies are becoming increasingly busy. So it's actually very important to look for other solutions to reduce CO2. And therefore, I want to introduce you to the project called IRIS. It's a technology that uses SATCOM for air traffic control. And in doing so, it could reduce fuel burn because it would allow much shorter flight paths because you would fly way more direct. It could also allow maybe other innovations or maybe even innovative solutions to capture solar energy. So that would be all very interesting. But today I want to focus on something else because I think this project is so interesting because unlike traditional ground-based data links, which you can see on the video, and which are, by the way, extremely congested, while satellites would allow for much more data availability. And then this would have many advantages because this would eventually allow you to increase flight capacity, which prevents you from building more aircrafts. Yeah, so, and it would also make air traffic way safer and more efficient. And this last thing is the most important thing because improved efficiency can eventually reduce CO2 because, well, this huge amount of data availability will essentially allow you to continuously optimize your flight paths and your air traffic, making it way more direct to fly from point A to B. So in doing so, you can actually save a lot of fuel, and that's why it's so interesting, I think. And that's what it's all about. So a little recap from the video. There are several SDGs that this project might tackle. So I don't know if you know, but the United Nations defined 17 goals in order to make the world a better place by 2030. And 4 of them are now presented in this slide. And SATCOM for aviation might have an impact on this because it can make air traffic safer, cheaper, newer, and it could eventually reduce CO2. So that's very interesting. Actually, I did an analysis about how much CO2 we could eventually save by this, and the results show that CO2 emission could be reduced by 10 million tons a year. So that's a lot because that's actually 1/3 of what's polluted in London every year. So let me tell you a bit more about how I came up with this. So there are essentially 2 flight inefficiencies that we'd like to tackle with this project. And the first one is indirect flight paths, and another one is holding patterns. So on average, European aircraft fly on average 40 kilometers more than necessary due to fragmentation of airspace. And while enhanced air-ground communication and continuous updating of trajectories could potentially reduce this inefficiency with 60%, which would result in a 1 to 2% fuel savings and reducing CO2 emission by 8.5 million tons a year. And then another inefficiency is holding patterns. So in this case, the pilot literally waits above the airport in order to get the air traffic controller on the line. And this is because these communication channels are increasingly overburdened and causing the pilot to perform these holding patterns. And on average, these holding patterns add on average an extra 12 kilometers to each flight. So in fact, this technology that I'm speaking about is IRIS. Well, this is about IP connectivity for real-life water tracking and real-life communication channels, and it could potentially reduce these holding patterns by 35%, which could reduce CO2 emission by another 1.5 million tons a year. So that's quite a lot, because you should look at this in a cumulative kind of way. And if you add this up every year, and assuming this would be implemented this year, well, 10 million tons a year per year would eventually lead to 140 million tons of CO2 reduction by 2030. And there's also a huge cost efficiency that goes along with this, because only looking at the cost of carbons, you would already save 1.5 billion euro a year. And this can add up to 17 billion euro savings by 2030. So yeah, those are big numbers. And especially now with COVID, it's very important to look for cost saving solutions. And, you know, climate change and climate solutions, they will always be there, especially in aviation. So I really think that this project is very interesting, and I think it's a good step towards more sustainable aviation. So yeah, I hope we can expect that this will be implemented soon, and that we have more air connectivity in the future. This was a story I wanted to share with you. I find it very interesting. I hope you did too. And thank you for your attention.